Hello and welcome, students. Today's elementary algebra discussion is going to be addition and subtraction of rational expressions. Now don't get too nervous or anything with the topic because it is difficult at first, but I think as we go along we'll do a lot of examples and you'll see how it goes and then you'll feel better about it. So as we begin, we'll look at addition and subtraction of rational expressions. To begin with, I'm going to put an example of something we've seen before that is a basic addition and subtraction of just plain fractions. So let's take negative 1/3 plus 5/6. And this is a review example. It's something we've seen in the past at one point in our mathematical lives. And how do we approach a problem negative 1/3 plus 5/6? Well, the first step, if you remember, is to get the least common denominator. So the first thing you want to do is find the least common denominator. So I'm going to write find the LCD, meaning the least common denominator. 6 and 3, the least common denominator is 6. That is, it's the smallest number that both 3 and 6 divide into. So for this problem, our least common denominator is 6 in this case. And so now we go on to our second step, which is now we must change each of these fractions to have the denominator of 6. We're going to change each of these fractions so that they have the denominator of 6. So that's the second step. Convert the fractions to have the new denominator. Convert fractions to have the new denominator. That's the second step. Convert fractions to have the new denominator. And how do we go about doing that? Well, if you remember, you need to figure out what times 3 gives you 6. And in this case, 3 times 2 gives us 6. So we're going to multiply the denominator and the numerator by 2. So negative 1 times 2 on top gives us negative 2. And then on the bottom you have your 6. In the second case, you already have a fraction with a 6 in the denominator. So all you have to do is just keep the same numerator, which is 5. So we're done with steps 1 and 2, and now we go on and we look at step number 3. And step number 3 is to combine these fractions. And how do we do that? We do that by combining the numerators, that is adding the numerators, but keeping the same denominator. So that's the third step, is to add the fractions. And just to remind ourselves, we keep the same denominator. Keep the same denominator. You do not add 6 and 6. You just keep the denominator of 6. And I won't explain why. That's for later, earlier actually. So here we go. Negative 2 6 plus 5 6. Negative 2 plus 5 is 3 6. Keep the 6 on the bottom. And that's the third step. We've added our fractions up, negative 2 plus 5, and gotten 3. And now the final step, which I'm going to call the fourth step, is to take a look at this fraction and, if possible, reduce it to lowest terms. And in this case, we're going to reduce this to lowest terms. So reduce to lowest terms the fraction 3 over 6. And just looking at that, a lot of people can do that in their head. 3 divides into 3 one time, and 3 divides into 2 twice. Okay? And therefore 3/6 is equivalent to 1/2, and that is your result. When you add the fractions negative 1/3 and 5/6, you get 1/2. And you have to follow this 4-step process in order to make it work at the end. All right. So now let's throw some rational expressions in. Let's add and subtract some rational expressions. And as I've said before, it's difficult, so you just want to go along with the examples. We'll start out slow, and then we'll get more difficult as we go. So here we go. Let's do some examples. We're going to be adding some fractions together, and they will be rational expressions, so they will contain variables in them. So here we go. Example A. Let's take 2 over 3y, 2 over 3y plus 1/4, or 1/4. 2 over 3y plus 1/4. So thinking back to what our 4 steps were just a minute ago, the first thing we have to do is find the least common denominator. And then we're going to convert our fractions. So our least common denominator, 3y and 4, well, let's just focus on the numbers first. 3 and 4, the smallest number they both divide into is 12. So off to the side, let me just write down the LCD is 12, but I'm not done yet because I have to remember my variable, y. So I'm going to say the least common denominator is 12y. Now, I need to change each of these fractions into a fraction that has 12y in the denominator. So here we go. 12y, and we're going to repeat the question. What do we need to multiply by this denominator to get 12y? And that answer is we need to multiply this by 4, because 4 times 3 gives us the 12 for the y. So if we do it to the bottom, we're going to do it to the top. And therefore, the first fraction is going to be 8 over 12y. No problem there. So now let's proceed and look to the second fraction in our sum. What do we have to multiply by 4 to give us 12y? We need to multiply this by a 3y. 4 times 3y gives us 12y. So we're going to multiply the numerator by 3y. And 1 times 3y is just 3y. And so now when we go down one more step, we're going to now take these two fractions, which have the same denominator, and combine the numerators, or add the numerators. So we have 8 plus 3y all over 12y. And it's as simple as that. Now some people might like to go and put the 3y in front of the 8, but either way this is fine and an acceptable answer. You want to make sure that you don't combine the 8 and the 3y because they're not like terms. This has a variable and this doesn't, so you've got to stop right there, as weird as it may look to you. All right, let's look at example B then. Let's get a little trickier now. We're going to keep looking at the addition and subtraction of rational expressions. So example B, let's take a squared over a plus 3, and let's subtract 2a plus 15 all over a plus 3. So that's a squared over a plus 3 minus 2a plus 15 over a plus 3. Now, if you look at these fractions, our first step is to find the least common denominator. And in this case, both the denominators are already a plus 3, and so that is our denominator, and we don't have to change our fractions. So the least common denominator is a plus 3, and we don't need to convert them. All we have to do is combine the top. In this case, we need to subtract the numerators, and this is the tricky part. We're going to write down a plus 3 as our single denominator, and in the numerator, we're going to have a squared minus, and then we're going to have this whole quantity, 2a plus 15. So, in order to represent that we're going to be subtracting the whole thing, I'm going to put it into parentheses. You don't have to when you get really good at it, and as you do more and more, it'll come second nature. But the key is, what you have to remember is, you're subtracting not only the 2a part, but you're also subtracting the 15, okay? As we look back up here, you're subtracting both the 2a and you're going to be subtracting the 15. You're going to subtract each term in that second fraction, in the numerator of that second fraction. So, keeping in mind, this is our problem. We're going to simplify the numerator. We're going to subtract. So it's a squared minus 2a minus 15. This is one of the most common mistakes that I see even my calculus students making, is they're forgetting to subtract everything over here, so don't forget that. All right, so on the bottom we have our like denominator, a plus 3, and now all we have to do is reduce this to lowest terms. Now at first it might not look like you can reduce this to lowest terms, but let's remember the keyword factor here. This top polynomial is factorable. So let's actually factor a squared minus 2a minus 15. A squared minus 2a minus 15. Two numbers that multiply to negative 15 and combine to negative 2. Let's see. I think that's going to be a minus 5, a plus 3. A squared minus 2a minus 15. That works. And then on the bottom I have a plus 3, and what do you know? I can reduce. I have an a plus 3 on the top, and I have an a plus 3 on the bottom, and therefore I'll reduce that to the number 1, and this just simply leaves us with a minus 5 as our result when we subtract those two fractions to start with. All right. Are you getting the hang of it? I hope so. Let's look at example C. Example C is going to be another one. It involves variables. And let me erase this other stuff first. Okay, example C. Example C says let's add the fractions 2 over 3t, 2 over 3t plus 6 over t plus 1. 6 over t plus 1. 2 over 3t plus 6 over t plus 1. The first thing we have to do is get common denominators. And in this case, it might look strange, but you have to get everything. Every single product here, every single factor has to be included in this denominator. So let's look at the LCD, the least common denominator. It's got to have a factor of 3, a factor of t, and the factor t plus 1. So it may look strange to you, but our least common denominator is 3 times t plus 1. So now we're going to go back to our original problem and find what our new fractions would be if we changed our denominators. So I'm going to write our fractions over the denominator 3t times t plus 1. And now we're going to go back and look at the previous ones and see what we have to do to change them. 3t, to get to this here, we need to multiply by t plus 1. And if we do that to the denominator, we need to do that to the numerator. So on the top, we are going to have 2t, right, distributive property here, plus 2. 2 times t plus 2 times 1, so that's 2t plus 2. And then in the second fraction, we have a t plus 1 in our denominator, and we need to get a 3t with it. So let's multiply that by 3t, and 3t on the top. And so 6 times 3t is 18t. We now have the same denominator, so all we have to do now is our next step, which is add the numerators. So here we go. Let's take 2t plus 2 plus 18t, and we will put that all over 3t times t plus 1. That looks pretty nice. Can we go any further? Yes, we can. 2t and 18t are like terms, so let's combine them. 2t plus 18t gives us a 20t plus 2 all over 3t times t plus 1. I'll box that. We could stop right here, and that is an acceptable answer. Some people might like to factor out a 2, but if you notice, you won't be able to cancel anything in the denominator. And some people even like to multiply this out and make this 3t squared plus 3t. Anything is fine, but I'm going to stop right there. That is acceptable. All right, so let's go ahead and let's look at example D. A little more challenging as we go, but if you follow the 4 steps, you should have no problem. So here we go. Example D. Let's look at the following. Let me pick a good one here. Let's take 2 over 5x squared, 2 over 5x squared plus 5x minus 4 over 3x plus 3. So that's 2 over 5x squared plus 5x minus 4 over 3x plus 3. Oh boy. Okay, well, what do we want to do to get our denominator? I'll give you a hint. The first thing you want to do is factor each of these so that we can look and see what our factors are. So, what can we do here to factor this? This is factorable, and we can pull out a 5x. So let me just rewrite. This fraction is actually 5x, and then we're left with an x plus 1. Double check to make sure I factored that correctly. That's 5x squared plus 5x. And now the second step is to factor this denominator, and that's a little easier. We're just going to take out a 3. So we're left with 3 times x plus 1. And let me just write next to this that all we've done from here to here is we've factored our denominators. So let me just write the big word factor. We haven't changed anything. We just factored our denominators. So now we can look at these denominators and say, hey, now I know what to do. Now I know what my least common denominator is. It's going to be 15 times x plus 1. And it looks very similar to the one we just did. So 5 times 3. So that least common denominator is 15 times x plus 1. And like I said, it looks very similar to the one we just did. 15x times x plus 1. And here we go. We're going to change our fractions. All right. So we need 15x times x plus 1 in the bottom. And we need over here 15x times x plus 1. Hope you guys are having fun. Here we go. On the top, we need to multiply this by 3 to get to 15x. So we have 3 times 2, or 6. And in the other one, we need to multiply this by a 5x, because we need the 15x. So we're going to multiply this by 5x. So on the top over here, we've got 20x. All right, put together our numerator. So we've got 6 minus 20x all over 15x times x plus 1. Can we reduce any farther? Well, we could factor out a 2, because 2 goes into both of these, but that won't cancel. So I'll just leave it just like this. Some people, again, might like to put the negative 20x in front of the 6, but this is fine. See how easy that was? Once you remember to factor your denominator, everything falls into place. So let's look at one big problem. This will be example E, and it has, actually it will involve a little bit of work, more than the other ones did. So example E, let's take negative 4 over z squared minus 16. Negative 4 over z squared minus 16 plus 3 over 2z plus 8. Okay. Let's see. What are we going to do? First step, like last time, is we're going to factor our denominators. We need to change our denominators. So let me just put in the word factor factor. Okay, I'll just write the word factor, but we know that means we're going to factor our denominators. So in the first example, we've got z squared minus 16. This is a difference of squares. So that's negative 4 over z minus 4 times z plus 4. Negative 4 over z minus 4 times z plus 4. And in the second example, again, we're going to factor. And I have 2z plus 8, so we're going to take out the factor 2, and we're going to be left with z plus 4. Okay. So now we need to look at these, excuse me, and get the least common denominator and make sure we get all the factors. So the least common denominator then is going to have to include the factor 2. It's also going to include the factor of z minus 4. And it's going to include, I'm losing my voice, the factor of z plus 4. And if you recall from last time, we went through a big process of finding least common denominators in the previous work. Well, we don't always have to do that. Sometimes we can just look at it and get our least common denominator. So once we get our new least common denominator, we're going to convert these fractions. So I have a negative 4 over 2 times z minus 4 times z plus 4. That's our first fraction. And then in the second example, I'm going to have 3 over 2 times the quantity z minus 4 times z plus 4. Again, our new fraction. And what am I going to put here? Well, I kind of jumped the gun here. I'm going to have to multiply this by 2. I forgot to put that in there. And I kind of just went right ahead and wasn't thinking. I'm going to take negative 4 times 2 and get negative 8. And in the second example, or in the second fraction, what do we need to multiply by over here? Here we need to multiply this denominator by z minus 4. Z minus 4. And so again, I jumped the gun, and I wrote the 3 down, and this is what a lot of people do. They just kind of forget to do the numerators. They just do the denominators, and they forget the numerators. Don't forget the numerators. All right, so here we go. 3 times z is 3z. 3 times negative 4 is negative 12. So let me double check since I was rushing there. Let's make sure we did this correctly. I needed to multiply this by 2, so negative 4 times 2 is negative 8. I needed to multiply this by z minus 4, so I multiplied that by z minus 4 and got 3z minus 12. Looks good. Now we're ready to go on and combine our numerators. So we have 3z, and I'm going to combine these two constants. I have a negative 8 and a negative 12, which is negative 20, all over 2 times z minus 4 times z plus 4. And I'm going to box that. 3z minus 20 over 2 times the quantity z minus 4 times z plus 4. And that is correct. Now, we're going to do one more example. This is an example with a tricky negative. In fact, factoring out a tricky negative. So, let's look at example F for the day. And example F says the following. Let's take 10 over m minus 2, 10 over m minus 2, plus 5 over 2 minus m. 10 over m minus 2 plus 5 over 2 minus m. Now, at first look, you might say, okay, the least common denominator here is going to be m minus 2 times 2 minus m. And you can go through and that will work. But I'll show you a little trick here. It's a little shortcut. These two can be written as the same expression if we factor from here a negative 1. So off to the side, let me write 2 minus m. Let's take out a negative 1. And what happens? Well, then we're left with a negative 2, which is kind of interesting. But negative 1 times negative 2 will give us our 2, so we're okay. And then when we take a negative 1 away from here, we're left with plus m. Let me see, that's 2 minus m. So far we're okay if we take a negative 1 out. Now, why would I take the negative 1 out? Well, see, by taking the negative 1 out, that now makes my m positive. And check this out. If I just switch these using the commutative property, if I just switch the place of these, I can write this as m minus 2, right? And now if we go back a second to our original problem, there, look, there's my m minus 2 again. There it is. So this is the same thing as an m minus 2, but it has a factor negative 1. And how do we recognize this? I think we've talked about this before. We recognize this because these are the same values, but they're written in the reverse order. So over here, I'm going to write 10 over m minus 2. And I'm going to factor this denominator as 5 over negative 1 times m minus 2. And we just did the factorization on the side. Okay, so let me just highlight that. We just did that factorization there. And now here's the trick, and we're almost done. This is a beauty. When you have a negative 1 here, you can actually move that negative to the top, right? If you're dividing by negative 1, it's the same thing as multiplying by negative 1. Or if you like, we have this rule that a negative in a fraction can float here or here. So here we go. I'm going to move my negative up. And I'm going to write this as 10 over m minus 2. And then I'm going to have plus a negative 5 over m minus 2. Oh, excuse me, m minus 2. And all I did again was I took my negative and I floated it to the top. I moved it to the top, which you can do. So combining the top, we have 10 minus 5, which is 5, and our denominator is m minus 2, and that was easy. Just have to know those two couple tricks right there. All right. Well, today's discussion was on rational expressions, the adding and subtracting of them. It's difficult. You'll feel kind of weird when you start them. It'll be difficult, but practice, 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 and let me know if you're having any problems. So I'll see you next time.